Yeah. Any questions?
Thanks.
Yeah, and the corpus of words that are occurring in the given block is all words that are in the text that you use?
Yeah, so typically they do something like they throw away every word that occurs less than 20 times,
Okay,
and then you just take everything that's left over.
so it's a lot.
It's a
And
lot.
a sample corpus would be like Wikipedia,
Mm-hmm.
for example.
And you can take pretty much as much text as you want. Yeah.
Where does K come from?
Oh yeah, good question. So K here is the, like I said, these guys and these guys are the word vectors associated with the word, so they define the point in space. So for each word then you've got K different numbers, so you're in a K dimensional space. So K is a number you choose before you even start. You say, when you find these skinny matrices, make sure that they are only K thick and K wide respectively. So you choose K to be a few hundred, which sounds like a lot, but for language it's not much at all. I mean, it's too much to visualize, but if you wanted to get, say, that diagram we looked at the beginning with king and queen and so on, you just set K to be equal to 2.
Do you get any differences of precision by varying K? Or?
Definitely, yeah. So what you're really doing is you're by choosing a different K, you're changing the severity of the compression.
Okay.
Like if you took K to be really, really big, like as big as this matrix was in the first place, then you could choose these guys so that you get that, so you get this matrix back precisely. You could take this one to be the original matrix, and you could take this one to be the identity, say. But if you take K to be really, really small, if you just think of each entering this matrix as a piece of information, right? Well, on this side you've got as many words in the vocabulary squared pieces of information. Whereas here you've got as many words in the vocabulary times K times 2, which is a much smaller number, much smaller number. So by choosing a smaller K, you're representing the same information using a smaller number of bits, essentially. Go on. Oh.
In your practical work, where do you run these computations on?
Yeah, so you can, I guess the neat thing about both these techniques is you can run them on your PC.
Okay.
I mean, we don't, but you really can. Like, you could train a state-of-the-art language model on your laptop. And before these guys came along, it'd take weeks, and it'd be on specialist hardware, and people wouldn't even publish their code. It was just a totally different setup. So there are kind of forums online for these two tools where everyone is asking questions about how to train word models. It's great. It's really cool. Yeah.
Can you go back to this word space slide with the mouse?
Oh, yeah.
So a mouse is well, near to cheese, but mouse is also a computer device.
Yeah,
Is
yeah.
that a problem for this approach, that the mouse has different meanings?
Definitely. I mean, so that's a really good point. So this thing totally ignores multiple meanings of words. Surprisingly, like it matters if you care about where mouse is in the space. That's a really good point. Like I don't know where computer would be on this diagram, but
Next to king.
yeah, but it's a really good point. So, yep, can't argue with that. So any word that has two meanings, you're going to get, the resulting word vector is going to be like a weighted sum of the two vectors if they had separate meanings.
Right, so you can imagine that, like, if you took corpora from different points in the 20th century, right, like mouse maybe starts out closer to cat and dog, and then moves closer to computer over time. Historical word embeddings
Would be really interesting.
super cool.
I think some people from Leipzig have done this with Google Books.
Oh, with the
1800 to 1850, from 1850 to 1900, and give different corpora from different time.
What do you use this for?
Oh yeah, so good question. So, right, so I should link it to what, for instance, yeah, so the examples I gave you were kind of probably not practical, like the machine translation thing. Like it's great to be able to translate words you don't know, but you could just use a dictionary. Like, I mean, you can get it wrong. Like, I mean, it's statistical, right? So it's definitely fallible. You can definitely trick it. And it's all dependent upon, like, you've got to train this thing on text, right? So if we train it on one corpora and it's in no way representative of what you're working on, it's problematic. So we spend a lot of time collecting text from anything you can think of. Just collecting huge amounts of text. That's the curation we do. And then we train the model on that. But I mean, ideally that's a case we want to solve. We really want to be able to do that. I don't know if you guys, you don't use Confluence, do you?
Yeah.
Okay, well we just finished the plugin for Confluence yesterday, so it's not on the market yet. But the whole idea is that you plug it in and it indexes all your stuff, and then it'll surface pages from Confluence based on what you're reading at the time.
Oh, we need that.
Yeah, it's correct. So we've got different models for different languages. So at the moment we've got English and Indonesian and German. With more to come, I suppose. It's just a matter of finding someone that wants it. Then we build it.
So if I'm writing user stories on Jira now, I can use all the user stories that are there to generate new user stories?
Unfortunately, it won't quite make you redundant yet. But it will kind of like, if you're writing that user story, you'll be able to see all the ones that are similar to it, thematically, which is hopefully helpful.
But how is it different from a retrieval model? I mean, why use word similarity and not just a retrieval model? Like you already have a document, you source the most popular terms in the document.
Yeah.
You search for those and get the most relevant documents back in.
Look, it's an excellent question and it's a really subtle point. So the whole thing is the ship boat thing, right? So like the thing about normal document retrieval is it's only got the knowledge that's in your documents. So if like we took all the Confluence documents from Babel and we indexed them, then we'll be able to use the words that occurred in them, or like a normal untrained computer could use the words that, if the words match, it can find them, right? But you guys are a reasonably sized company, right? But you haven't got enough text that I can learn that ship and boat mean the same thing. So what I have to do is pre-train the model on a huge amount of text, and then bring that residual knowledge to your documents. So you might have a few thousand pages. The whole idea is you learn on heaps of other stuff, and then we bring that learning to your documents so that we can realize that ship and boat mean the same thing. So when your document says ship, I can also surface the boat one. That's the...
For example, if Confluence could see, oh, you're writing a page about content blocks, let me show you a page about chapters.
There's a huge glossary for that as well.
Or you
Can learn on the glossary.
Oh, lesson. Right.
Yeah.
I could.